Hi guys, good evening. So in the last session we saw about OSPF. Now today we'll go with the ACL, Access Control List. So what is ACL? ACL is a set of rules that are defined for controlling your network traffic and reducing your network attacks. You want to control the traffic that to your router, who can send the traffic, who cannot send the traffic. That means we will decide that okay, what kind of traffic we want to allow, what kind of traffic we do not want to allow. So far, the default behavior of your router is what? That if your router has a route, router will provide communication. Router will start communicating. Okay. And if somebody is sending traffic to the router knows the network, router will allow the traffic. This is the default behavior that router will allow the traffic. So what we can do here, we can configure a rule that, okay, allow this traffic, do not allow this traffic. Based on that, router will take the decision. Okay. So ACLs, they are used to filter your traffic based on set of rules defined for incoming and outgoing of the network. So we can filter the traffic either in the incoming direction or in the outgoing direction. Okay. The incoming traffic I can filter, the outgoing traffic I can filter. Okay. So for this reason, we have to do what? We have to create ACLs. And these ACLs, once you create the ACLs, we have to apply the ACLs. We can apply the ACL in the inbound direction or the outbound direction. Now, what do we mean by inbound and outbound? Okay. So if you look at the flow of your traffic, if the traffic is incoming, that means inbound. If the traffic is outgoing, that means it is outbound. Okay. Same way you can name the traffic incoming traffic or inbound traffic, outgoing traffic, outbound traffic. Same way you can name the interface also. Inbound interface, the interface on which the traffic is incoming. Outbound interface, the traffic on which the traffic is outgoing. Right? Okay. Now let's talk about it. The inbound and outbound interface. Once the access list is built, once you have created the access list, then it should be applied to either inbound or outbound of the interface. Okay. So the interface through which the router receives the traffic, the interface on which the router is receiving the traffic, that will be what your inbound interface, because the traffic is incoming. Okay. And the traffic will be known as what? Incoming traffic. Outbound interface, the traffic through which your router will transmit, the interface through which the router will transmit, that will be known as what? Outbound interface. This is clear. So the traffic which is going out of the router, which will be known as outgoing traffic. This is clear. Okay. Now, if we talk about type of ACL, so we have two types of ACL, standard ACL and we have extended ACL. Okay. And to define ACL, we have two methods. One is the named method, second is the numbered method. These are the two methods, both in the standard also, extended also. Okay. So if we talk about the numbered range, okay, the range of numbers that you can use here, 1 to 99. This is the number range for standard ACL. Okay, this is the normal range. We do have an extended range here, which is 1300 to 1999. This is the range. That means basically you can create more number of access lists. These numbers, these are used to differentiate between the access lists, like access list 1, 2, 3, 4, like that. So by default, you can create 99 access lists for the standard. But later on, what if you need more? You can use these numbers. Same way in the extended, it was 100 to 199 and 2000 to 2699. Okay, these many access lists you can have standard as well as extended. This is clear. Okay. Now, if we talk about the difference between your standard and access list, extended access list, so there is one major difference, only one major difference. Okay. So what is the difference? Today keyboard is problem. One major difference we have, that your standard ACL will filter the traffic based your standard ACL will filter the traffic based on source IP address only. It will filter based on source IP address only, while your extended will filter based on source, based on destination, protocol, and port number. This is clear. This is only the major difference. Based on this difference, you can make many differences. What here you are able to give the protocol and port number also. That means specific protocol I am able to filter. I can say port number 80 TCP means what? I will filter HTTP. If I will say, okay, port number 53 UDP, that means DNS. So this way I am able to filter a specific service. But here, am I able to give anything? No. If I'm not able to give anything, so based on the source IP, I can filter a network, I can filter a host, I can filter a subnet, but I cannot filter a service. But here I'm able to give, so I'm able to also filter a service. So this is only one major difference. This is only one major difference. Just looking at this difference, we can make so many differences. Why? If you are blocking only source IP, that means you're not specifying any service. So automatically all the services will be blocked. And here you're specifying a service. That means you can block selected services, right? Now here, again, we cannot specify, let's say ICMP traffic. So in ICMP, we have request and reply. ICMP echo request, type code 8. ICMP echo reply, type code 0. So I'm not able to specify these things here. I cannot specify protocol. I cannot specify port number or message type. So what will happen? Both side communication will be blocked. But here, if I will specify that only message type 8 should be blocked, that means only request will be blocked, reply will not be blocked. So here, one-way communication is stored. Then the number range, I have already explained this thing, that we can use numbers to differentiate between the ACL. Then your standard ACL, we say it is implemented closest to the destination, and your extended ACL, it is implemented closest to the source. Now this thing, let me explain why. Okay. Remaining difference is clear? Okay. Depending on our requirement. Depending on our requirement. If you don't know, if you want to block all the services, you can go with the standard. If you want to block a selected service, you can go with the extended. So depending on what is our requirement. Sometimes, let's say I have a web server. So I want that, okay, nobody should be able to ping my web server, but they should be able to access the website. So ICMP I can block, and remaining everything I can allow. So that will completely depend on my requirement. That what is our requirement, and based on the requirement, we will decide standard or extended. Both are used. Okay. So consider here, let's say I have a network setup, something like where I have R1, I have R2, I have R3. These are the three routers I'm having. On this side, I have one PC. This side, I have one PC. This side, I have one PC. Okay. This is R1. What problem today? R1. This one is R2. This one is R2. This is PC1, PC2, PC3. Okay. This one, let's say Z0 by 0, Z0 by 1, Z0 by 0, Z0 by 2, Z0 by 0, Z0 by 1. And this is Z0 by 1. Okay. Consider I'm having a network 10, 1, 1, 0 slash 24 here. Here I'm having 10, 2, 2, 0 slash 24. Okay. And this side I'm having. So here I have the IP dot 3. And here I have dot 30. Okay. This side I have dot 3. On this side I have dot 2. On this side also dot 2. On this side also dot 2. Here I have dot 1. And dot 1. This guy has dot 10. And this guy has dot 20. In between R1 and R2, 12.0 slash 24. And here 23.0 slash 24. Okay. Now let's say, what is my requirement? I want that, okay, PC1 should not have communication with PC3. This is my requirement. Okay. Now I can create access list. And if I will create, let's say, extended standard access list. So standard access list filter based on the source IP address only. That means when I create the ACL, my ACL will look something like that. If source is equals to 10.1.1, 10, what should be the action? Action should be denied the traffic. I have created this kind of ACL because it will, okay, font. Okay, fine. Oh. So let's say this kind of ACL I have created, that if the source is 10.1.1.10, action should be what? Deny. Okay, all right. Now I have to think that, okay, where I'm going to apply this rule. Okay, so this will be my traffic flow when my PC1 wants to communicate with PC3. This is my traffic flow. Correct? Let's say I'm thinking of applying it on R1. I'm thinking to apply it on R1, that I will apply my access list on R1. And let's say I will apply access list on this interface. Okay. So if I want to apply it on this interface, what will be my direction, inbound or outbound? Inbound, right? Because on this interface in the router, traffic is incoming. Okay. So that means here I came to know about the direction, that if I have to apply here on this interface, it will be inbound. On this interface, it will be outbound. Correct? So if I try to apply it on this interface, okay, let's say I have applied. Now what? This PC will generate a message to communicate with the PC3. So when PC will generate a message, your PC will say that source IP. Okay, your PC will say source IP 10.1.1.10, destination IP 10.3.3.30. Right? This message will arrive on this interface. Router will see that, okay, I have a ACL applied here, and my ACL says if the source is this, I have to deny the traffic. So what will happen? This traffic will be denied. That means PC1 will not have communication with PC3. Any problem? No. Our rule, our condition matched. But imagine PC1 wants to communicate with PC2. So what will happen? Source IP this, destination IP will be 2.2.20. Traffic will come here. Router will check the ACL. What will happen? Now, is this our requirement? That PC1 should not be able to communicate with PC2? No, this is not our requirement. My requirement is only this. My requirement is only what? That my PC1 should not communicate with PC3. I'm not saying that it should not communicate with PC2 also. So what is happening if I'm applying here? So can I apply my standard access list here? No, I cannot apply. I cannot apply here. Okay, can I apply on this interface? If I try to apply here, so first of all, I have to apply here in the outbound direction. But again, when my PC1 will try to communicate with PC2, again source IP will be checked, traffic will be dropped. Can I apply here? I cannot apply. Again, traffic will be dropped. Can I apply here? So yes, I can apply here. But the thing is, if more than one PC is there this side, again there will be a problem. So where I have to apply? Here. I have to apply it here. And this is why we say standard ACL is applied closest to the destination. Because when you apply closest to the source, your other communications are also going down. Is that clear? Right? Yeah, your standard ACL you will apply always closest to the destination only. This is clear. Now let's talk about extended access list. Now let's say my requirement is what? That PC1 should not have communication with PC3, but what kind of communication it should not have? Let's say something like now this time my requirement is PC1 should not ping PC3. This is my requirement. Okay. So according to this, if I want to create the ACL, how my ACL will look like? My ACL will say if source equals to 10.1.1.10, destination equals to 10.3.3.30. Protocol for ping which protocol? If the protocol is ICMP and if the message type is H, in that case, action should be what? What should be the action? Deny. This is clear, right? This is clear. Okay. Now, let's say I created this ACL and if I apply it here, because we say that, okay, extended ACL applied closest to the source. What if I apply it here? So what will happen when my PC1 will try to communicate, my traffic will come here. Then after here, it will check this router R3. That, okay, is the source 10.1.1.10? Yes, it is. Is the destination 10.3.3.30? Yes, it is. Is the protocol ICMP? Yes, it is. Is the message type 8? Yes, it is sending a request. So what is the action? Deny. So if I have to deny this traffic, then why would I allow this traffic up till here? Why would I have some extra traffic? If this is traffic, I'm not like, I do not want this traffic in my network, right? I do not want this communication. So why should I allow this communication to travel that far in my network? I can save that amount of traffic. I can save that amount of bandwidth. That can be utilized for some other kind of traffic, something that is useful for me. So for that reason, otherwise you can apply it anywhere, no problem. Okay, it is not a restriction, that you have to go and apply close to the source only. If you want to save your bandwidth, apply close to the source, otherwise apply anywhere you want. You can apply here also, it will work the same. Here also, it is going to work the same, here as well as here. Anywhere you apply, it will work the same only. But if you want to save the bandwidth, then you go and apply it near the source itself. If the traffic will be denied here itself, then why to go that far? This is clear? Online people? That's clear? So why standard will be applied close to the destination? Why extended is applied close to the source? This is clear? Okay. Now, this topic here is access control. Is it clear? All right. Now, let's see how you'll configure the access list. Okay. Both ways I'll show you. Standard also, extended also, named also, numbered also. So first thing, okay, the first configuration. Let's say I'll use what? Numbered standard ACL. Okay, numbered method I'll use. So how do you define numbered ACLs? You will see access list. See, your numbered method comments, they will directly start from the word access list. Okay. So you will say access list. You will give a number between 1 to 99 for standard. Okay. See, in packet tracer, it does not support 1300 to 1999. So that's why I'm saying 1 to 99. Okay. In the real scenarios, you can use both of them. Then after, you will see that whether you want to permit the traffic or deny the traffic. What is the action you want to take? Okay, you will define the action. Then you will define the source IP address, either source IP or network. Okay, and according to that, you will give the wildcard mask. According to that, you will give what? Wildcard mask. Now, okay, before this, one more thing. Before this, there's one more thing I need to discuss. There are few rules you need to know about ACL. Rule number 1. You can apply only one ACL per interface per direction. Okay. So on one interface, total of 2 access lists you can apply, one in inbound, one in outbound. Okay, so per interface, per direction, only one ACL. You cannot apply more than one ACL. Is that clear? This is first rule. Rule number 2. At the end of every ACL, whether it is standard or extended, doesn't matter. At the end of every ACL, there is a implicit deny statement. There is an implicit deny statement and this hidden deny statement. Okay, this implicit deny statement is hidden. So what it does, there is an implicit deny statement that denies all the traffic other than the ACL configured. Other than the ACL configured. So what do you have to do? You have to give a permit statement to allow rest of the traffic, or you can say or to bypass the implicit statement. Okay. See, there are two types of rules. One is implicit and another one is explicit. Okay. If we talk about type of rules, this is applicable everywhere, not just in your ACL. Either it is firewall or whatever, wherever the rule thing is there, you can always say there are two types of rules. Okay. What are those? Number one, implicit. And number two is explicit. Implicit rules, these are the rules which are system defined. Okay, you can say system defined or predefined. Okay, and in most cases, you will not be able to modify them. Cannot be modified. Okay. Explicit rules, these are user defined rules, what we are configuring. These are user defined. So if the user is creating the rule, that means user can modify and delete out. This is clear. Now understand C. First of all, you can apply only one ACL per interface per direction. So on one interface, we can apply only one ACL in one direction. Okay. And like I said, there is a at the end of every ACL, there is an implicit deny statement. That means it is a system defined and you cannot modify it. Okay. So what that statement will do, it will deny all the traffic. So let's say, for example, I have configured a traffic that, okay, my PC1 should not ping PC3. So this is the ACL I have created. So according to this ACL, let's say I have applied this ACL here on this interface, right? And what is the ACL saying? That deny this traffic. So when PC1 will try to ping PC3, it will see this rule. And what is the action? Deny. This traffic will be dropped. But when PC1 will try to communicate with PC2, source IP will be this, destination will be this, protocol will be ICMP, let's say, and message type 8. Message type is 8. When this traffic will come here on the router will say, I have only one ACL configured. And it says what? That if the source and destination and protocol, this thing, the action is to deny. But other than this, there is nothing else configured. If nothing else configured, that means what? The last implicit deny statement will come in picture. And what that statement is going to do? Don't allow this. It will deny all the traffic. So even you have configured correct ACL, still your PC1 will not be able to communicate with PC2. Why? It will deny the traffic. So we will have to give a permit statement here. Like once you have given all your deny statements, after that you will have to give a permit statement also, that if source equals to any, destination equals to any, and protocol, all the IP protocols, action should be what? Allow or permit. Okay. Protocol is IP, so action should be permitted. So ACL is always read line by line in sequence. So first of all, you have configured this rule. First of all, the PC1 going to PC2, it will match with this rule. Is it matching? No. Then it will match with this rule. Matching? Yes. So action will be taken permit, and your implicit deny statement will never get triggered. Right now, when I'll configure the ACL, you will understand this thing. Okay. But your ACL will always be checked line by line in sequence. Is that clear? Okay. So now let's see how you'll configure the ACL. Problem today. Okay, this is how you will configure the statement of ACL. And if you want to permit rest of the traffic, in that case, you will give the statement access icon list. Okay, whatever the number you are using, same number you have to use, whatever the number you have used here. Then after you will say permit any. That means permit the traffic from any source. Now, once you have applied the ACL, you have to apply it either in inbound direction or outbound direction. So first of all, you will select the interface, on which interface you will apply. So you will say interface and then interface name. And then you will say IP, access group. Then after you will give your ACL number, whatever the number you have used here. And after that, you will say whether you want to apply it in the inbound direction or outbound direction. This is how you will configure your numbered standard ACL. This thing is clear. Let's see it practically. Okay. So let me. So what I'll do here, I'll take a router. Okay, and I'll take a server. Just keeping the topology small only so that it will be easier to understand and will not be confusing. Let's connect them. Why we have taken server? Because so that we can use two services like HTTP and LCMP. Okay, so later on in extended ACL, this will be helpful. And this is your router where you will configure what? ACL. Okay. So let's say we are using the network here 10.0/24. Okay, so here all IPs .1 I'll be using like 30.1, 20.1, 10.1. Ten dot 10, 20.20, 30.11. Okay, these are the IP addresses. Let's go and quickly configure them. Ten dot 10, 10.1, 20.20, 20.1, 30.100, 30.1. Router IP configuration. Enable configuration terminal, ACL, interface, gig 0/0, IP address. Then we have 20.1, 0/2, 30.1, no shutdown. Clear? Now right now you'll see that, okay, my PC1 will be able to have communication with server. First packet will be dropped due to R, then you'll have communication. Okay. Now, the requirement is what? PC1 should not have communication with server. This is the requirement. So if I look at my traffic flow will be what? This. Which interface will be inbound, which will be outbound? Correct. Okay. And if I'm applying standard ACL and if I apply ACL here, so even PC2 communication will be blocked because it will just check the source IP. So when my PC1 will try to communicate with PC2 also, the traffic will be dropped. Why? Because here it will check the source IP. So where we are going to apply it? 0 byte. This thing is clear to everyone? Okay. So now what I'm going to do is I'm going to apply the ACL on Z0 by 2 interface in the outbound direction, because here my traffic direction right now is this. So Z0 by 2 will be my outbound interface. So the direction will be outbound. Okay. Let's go and apply it. Go to the router. You will say access -with 1. And right now I want to deny the traffic. So I'll say deny. If you want to deny the entire network, that entire 10.0 network should not communicate. So what you will give? You will give the network ID. Then wildcard /24. This is how you can do it. Okay, if you are giving a single IP, if you are saying that, okay, I want to block 10.10 only, so wildcard will be 4 times 0, because subnet mask will become 255.255.255.255/32. Right? This is confusing. Right? Tell me. For a single IP address yesterday. Okay, right? Understood? Okay. So either you can go with this thing for a single IP address. If it looks confusing, you can say deny host. You can use the keyword host. Host means what? Single IP address. And then you can give the IP address here. Then that deny this host. This will be easier. And when you're giving network, then you can give wildcard. Okay. Done. My access list is created. But I need to permit rest of the traffic. But right now I'll not give that statement because I want to show you how implicit denies work. Okay. Now access list is created. We need to apply it on the interface. On which interface I will apply? Z0 by 2. Okay. Because it is standard. I'll apply it here in the outbound direction. So I'll say interface gig0/2. And I'll say IP access group. What is the ACL number? 1. And direction will be outbound. ACL is applied. Let's see whether PC1 is having communication or not. So my first requirement was what? That my PC1 should not have communication with server. So you can see I'm getting what? Destination host and region. No communication. Who is replying? You can see 100 is not replying to me. Understood? This is clear. See, what is the error message? If you are getting a reply, you will get a reply like this. And reply will come from your destination only. But right now, not coming from the destination, coming from your gateway. Your gateway says, I don't know how to reach it. Why? Because the gateway is blocking the traffic. Clear? Okay. So, okay, fine. I was blocking PC1 to server communication, but my PC1 should be communicating with PC2, right? That communication should be there. So let's see. So I should have the communication because I did not create any ACL for this. So I will be having the communication. No problem. Did I create any rule for PC2 communicating with the server? No. So PC2 should communicate with the server. But here, due to the implicit deny statement, . due to implicit deny statement will not communicate. Why? Because implicit deny will say you have configured one ACL that PC1 should not communicate with server. You have configured one ACL that PC1 should not communicate with server. So other than that statement, I will not allow anything. I don't care, you are permitting the traffic, you're denying the traffic, but whatever you have given, other than that, I will not permit anything else. And this is why PC2 is not having communication. Okay. And if you go on the router and if you check the access list, to show access list, it says deny this host, right? Below this, there is a blank line. This is what your implicit deny, which is saying something like how your implicit deny is working here. Your implicit deny is saying something like here, you can say 20, deny any. So what will happen? Now, when you create the ACL, your ACL, when you try to communicate from PC2, okay. So first of all, your ACL is matched here. Says no, this is not the host 10.10. Second is what? Now, if I have to deny everything, I will definitely deny everything. I don't care where it is coming from. This is why your PC2 traffic is getting denied. So that means we have to bypass this. We have to bypass this. So what we'll do, we'll give a permit statement. And the permit statement will come above this. And automatically it will be bypassed. So in that statement, it is saying deny any, I will say permit any. So rest of the traffic will be permitted. Okay. So how you will give that statement? You will say same ACL number. Okay, whatever the ACL number you have used earlier, same ACL number you have to give. You will say access list 1. Although it is not case specific, same number you have to use. Okay. Now check the access list. Do show access list. First is deny this host. Second is permit anyone. And here you're deny anyone. So that statement will never get triggered. Why? Because first this statement will be checked. If not matching here, here it will definitely match. Okay. And now you can see that your PC2 will have communication with the server. This is how your implicit deny works. Clear? Right? Online people? Okay. So this is your standard numbered access list. Now the same thing we will perform using named access list. Okay. So in the numbered access list, what is the thing? That when you check the ACL, you don't get any idea that why you have created this access list. It will just say you that, okay, you have a standard IP access list and number is 1. Why you have created, who is this guy? We don't know. Right? So we will use the named method. So here I'll say this is named standard access list, or simply let's say ACL. Okay. So you'll see the named method comments will start from IP. So you'll say IP access list, then you'll use the keyword standard, then you'll give a name to this access list. Whatever the name, you can give it anything, up to you. You can give your name also, no problem. After what to do with it? Oh, let it be. Okay, let it be. So you'll say IP access list standard and name, and then directly you'll start with a sequence number. Sequence number is optional. Okay. Sequence number is completely optional if you want to give. Then after you have to give whether you want to permit or deny. Okay. Then after you can say again you can say source IP or network. And if you are using single IP address, you can use host. Okay. And then you give wildcard mask. Clear? And if you want to permit rest of the traffic, you will say permit any. Okay. Then if you want to apply it on the interface, so you will just go to the interface name. Only difference will be what? That instead of ACL number, you will give name of ACL. Remaining will be same. So you will say IP access group. Then you will give here ACL name. Then whether inbound or outbound. This is how you configure it. Now it works fine. This is clear. So this is how you'll configure named standard ACL. Let's go and configure it. We'll have the same effect. Okay. So now if I want to remove the ACL, first of all, I have to say that, okay, on the interface, I applied it. So from the interface, I will remove it. So I'll say interface gig 0/2. Then I'll say no. And this was the command I gave. So I'll just copy and paste it. Remove from the interface. And then I'll say no access list one. And it will be removed from. Okay. Now you can check do to access list. There is no access list. And now your PC1 should be able to communicate. Now your PC1 should be able to communicate. Okay. So you can see PC1 is having communication with PC2, and you can see PC1 is having communication with the server also. Fine. Okay. Now let's go and create the ACL. So I'll say IP access list and standard access list I'm creating name. So I will give a relevant name, like I can name it something like block PC1 to server. This kind of relevant name I can give so that later on when I'll check the ACL, I can see that why I have created the ACL, right? Then I will use the deny statement that deny the host 10.10. If you are giving network, then network ID and wildcard mask. Then to permit, I'll say permit any. Exit. Same exit interface will be Z0/2 outbound direction. Why? Because standard ACL. Okay. So even this standard ACL, we will apply it closest to the destination here only in the outbound direction. So I'll say that interface Z0/2 IP access group. Now ACL name is this. Make sure your name of ACL is correct. So better is copy paste. And I want to apply it in the outbound direction. Okay, now let's go and check. PC1 should not have the communication. So PC1 is not having the communication. PC2 should have the communication. So PC2 will have the communication. This is what was our requirement. This is how you can configure name standard ACL. Clear? Okay. Now let's go with the extended ACL. So with the help of extended ACL, we will block specific service. Okay. So right now on PC1, let me show you that, okay. Okay, right now I'm having ACL. So let me first of all remove this ACL and no access list. Okay. So I'll use this direct command in the, I'll copy this. I'll say no. Okay, it is removed. So access list. So no access list. PC1 should have the communication. PC1 is having the communication. Now what? On PC1, you can see I'm able to ping. That means ICMP protocol access I'm having. I'm able to communicate using ICMP. And also, if you see, I'll be able to take a web access of the server. That means HTTP access also I will have. So if I go and type here, server IP address 192.168.30.100, you can see I'm having the web access also. This is a sample packet tracer website. So I'm having HTTP access also. Okay. So what we'll do, we'll block ICMP. This time we say that, okay, PC1 should not be able to ping the server, but it should be able to take a website access. Okay. This will be our requirement. So let's see how you'll configure. We'll use the numbered method first. So you'll see numbered extended ACL. And here you will see the numbered method command will always start from access list and named method IP access list. The number range here you will use between 100 to 199. Then here you will give the action whether you want to permit or deny. Then you will give the protocol here with protocol. Then you will give the source IP or network. Okay, then wildcard for the source. Then you will give destination IP or network. Then you will give the destination wildcard. Then you will give the port number, either the port number or message type. Port number or message type. This is how you'll configure it. Okay. And if you want to permit rest of the traffic, you will say access hyphen rest 100 to 199. Permit all the IP protocols from any source to any destination. This will be your permit statement to bypass the implicit statement. To apply it on the interface, the command will be same. You will say interface. Yes, one for source, one for destination. Any source, any destination. Interface name, and you will say IP access group, same way. Same like your standard one. ACL number and whether inbound or outbound. This is clear. So this is how we are going to configure the numbered extended ACL. Now let's see it practically. So we will block ping and remaining everything HTTP will be allowed. And also I will show you that one-way communication will be blocked, not two-way. Okay. So let's go on the router. And here let me configure the access list. Now extended ACL we apply it closest to the source. So that means this time I will apply G0 by 0 And what is the direction? Inbound. Okay. So I'll create my rule. I'll say clear this one. Access hyphen list number 100. I'll say I want to deny the traffic. Which protocol I want to deny? ICMP from where? Now again, source network, source wildcard, but we are using single IP address. So from the host 10.10 to the host 30.100. Okay. And what kind of message you want to, if you want to block complete ICMP, then you just hit enter. If you want to block a specific message type like message type 8, then you will say 8. Message type 0, 0. Okay. So let's say right now I want to block message type 8. You can say this, hit enter. Then after we have to permit rest of the traffic. Access list 100. Permit all the IP protocols from any source to any destination. Okay. Now I have to apply it on the interface. I'll say interface dig0/0 IP access group 100 and inbound. Right? On the Z0/0 in the inbound direction. Enter. Let's check. Let me go to PC1. This is PC1. First of all, let me test the ping, that whether I'm able to ping or not. Not able to. Right? Am I able to take a web access? So now if I try, I have the website access. Okay. And like I said, one-way communication will be blocked. So you can see PC1 will not be able to ping the server. Why? Because message type will be 8. So PC1 is not able to ping the server. But if I try to ping from server to PC1, I will be able to ping. See here. Ping. This is one-way communication blocked. Why? Because when PC1 will reply, it will be message type 0, not 8. So it will be allowed. Clear? Now let's see the named method. So in the named method, we will do the reverse thing. We will block the HTTP and we will allow the ICMP. Okay. So first of all, let me remove it. No. No access list. 1. Do show access list. Okay. So I check. No access list is there. That means now PC1 should be able to communicate also. Okay. Now let's see about the numbered method. Sorry, numbered already seen, named method. So now we will see named extended ACL. So named method command will start from the word IP. So I'll say IP access list extended and I'll give a name. Then after I'll directly say sequence number, again optional, and this time I'll show you what is the use of sequence number. Okay, sequence number. Then you'll give whether you want to permit the traffic or deny the traffic, the action. Okay. Let me do one thing. If how you define it is the same, just the starting is different. That here in the number method, every time you have to type this access list 100, access list 100. But here one time you type, then after directly you can start with permit, deny, whatever the state. Okay. Same way, if you want to give a permit statement, you'll give here and then directly permit or deny. Okay. You want to apply it on the interface, same method. This is how you can apply it on the interface. Okay, so not very much difference. Okay, so let's go and do it. Now on the router, I'll define the ACL. I'll say IP, access list, extended name. Let's say I'll say something like block, PC1, HTTP, 2, cover. Relevant name I'll give so that when I check the ACL, I can know what I'm doing. And I say that I want to deny. Which protocol I want to deny? Why ICMP? ICMP we denied previously, this time HTTP. Now HTTP is based on which protocol, TCP or UDP? TCP. So we will block TCP port number 80 communication. So I'll say deny the TCP protocol from which source? So I'll say host 10.10 to the host 30.100. And port number is what? Single port number. So if you are having single port number, you will use port number equals to. If you are having a range of port number like less than this port number, then less than LT, greater than GT, like this you will use. Okay. So right now single port number, so I'll say port number equals to. Okay. And what is the port number? 80. This is the traffic I want to block. And rest of the traffic, permit all IP protocols from any source to any destination. Let's apply it. Interface gig 0/0. Then IP, access group, ACL name, and then I'll say inbound. Done. Now let me go on PC1. First of all, let me try the ping. Able to ping, but this time I should not have the HTTP access. So if I go here on the web browser, okay. So if I try 192.168.30.100, I should not be able to communicate. So you will see I don't have communication. And same thing, see, this is PC1 who is not able to access. But if I check PC2, okay, here what I get? Request timeout. Okay, here I'm getting what? Request timeout. And same thing if I check on the PC2. So we have permitted rest of the traffic. Okay. So you will see on PC2, we will have the access because we did not create the rule for PC2. Okay. Here if I try, we have a statement. Okay, we have the access. So PC2 we will have, PC1 says request timeout. Why? Because the packets are being dropped. Okay, this is clear. Yeah, sequence number I'm showing you now. Let's say, for example, right now PC1 is not able to have the web access, right? And I want that, okay, PC2 should not be able to take a web access also. Okay. Or let's say I want, but for that I'll have to go and create a new access list. Okay, let's say I want that, okay, PC1 should not be able to ping PC2. This is the rule I want to create. Okay. The rule that I want to create is what? PC1 should not be able to ping PC2. Right now I can see here that my PC1 will be able to ping PC2. Okay. This is my PC1. And if I try to ping PC2 from here, I'm able to ping. So I want to deny this traffic. So again, this traffic will be in this direction only. So I will apply the ACL on this interface in the inbound direction only, which is already applied, this same ACL. So in this same ACL, I will add one more entry. See, in one list, you can have multiple entries. Okay. So what I'll do here, I'll say this comment, copy and paste. I went into the ACL. And if I want to deny the traffic, what I'll say, deny which protocol? ICMP from the host 10.10 to the host 30.100, right? And the message type is what? 8. Done. Now let me check. Doesn't work. Why? If I check my access list, do show access list. This is the deny statement. But do you see before this statement, I have another statement. Permit all the IP protocols from any source to any destination. So when my PC1 will try to ping PC2, it will check the first statement that is it matching? No, because it is not, it is going from 10.10 to 20.20. And this rule is different. And also protocol is ICMP, not TCP. It will come on the second rule, permit everything. So definitely it is matching here. That means your rule will never get triggered. Why? Because the sequence number here is what? 30. So what I will do, I can modify this sequence number and I can make it something in between 10 and 20. So that this rule will come in between 10 and 20. That means your deny rules, they should always come before your permit statement. So if you want to inject the rules, you are creating a new rule and you want to inject the rule before your permit statement, then you can use the sequence number. Sequence number is possible to use in the named method only. In the numbered method, it is not possible. Okay. So what I'll do, see here. This is the statement I give that deny ICMP from the host 10.10 to, sorry, not this one. Okay, sorry. Here I gave a wrong statement. I gave to 30.100. Let's say I want to deny it for 20.20 so that we can verify. Now click to show access. Now you can see that I have created rule for PC1 to PC2, deny the ICMP protocol message type 8, but still you will see PC1 will have communication. Why? Because of this permit statement. So now this time what I'll try to do is I'll try to bring this statement before 20. So how I'll do it? I'll remove this statement first. And I'll say that, okay, I want to deny it, but I want to use sequence number what? 15 here. Now check. Any number, 11 to 20, anything you can do. Do show access list. Now you can see the rule came here. And once the rule came before your permit statement, now this rule will be matched and you will not have communication. This is how you can use the sequence number to inject the rules in between. Is that clear? So this is how you can use your access list to filter out your traffic. Any doubt? No? Clear? Online people? Guys, clear?
Clear.
Okay. So this was your complete ACL concept. Okay, let me see. So today we'll do this one concept only. Okay, will not go more. This is 2 p.m. Any doubt? No? Sufficient? You practice this? Okay. Okay. Now next session. Okay.